Hey guys, so here's part 2 of the 3.2 day 1 notes. We're going to now use the properties that you just took down to evaluate or simplify the expressions. Okay, so part A, we have 7 to the 1/4 times 7 to the 1/2. So notice here that we have the same base and we're multiplying. That means we are going to add our exponents. Okay, so notice here when we add our exponents, they do not have the same denominator. So that means we have to get them to be like denominators in order to add. So that means we need to find a common denominator, meaning what is a number that 4 and 2 both can go into? Well, that would be 4. So 1/4 stays the same. However, on the other one, what do we have to multiply 2 by to get 4? 2. So that means we also need to multiply the numerator by that. So do 2 times 2, so this gives that. So now I'm going to add, so 1/4 plus 2/4 equals 3/4. So then my answer here is going to be 7 to the 3/4. And that's going to be my final answer there, okay? Now, just going to let you know, notice that we are in rational exponent form. So make sure when you get your final answer, you write it as rational exponent form. So whatever form they give to you in the problem starting off, that should be your final answer. So like B, notice we start off in rational exponent form. So if we get a rational exponent, that means you need to leave it. So don't change it into radical form or radical notation. Okay, notice here we have 6 to the 1/2 times 4 to the 1/3 squared. So we have different bases, but raised to the same power. So what we will have to do is distribute it to both of these. So I'm going to multiply, so I have 1/2 times 2. So that should just give me 6, or 6 to the first power. And then 1/3 times 2, that gives me 2/3. Okay, now here I do need to ask you guys, do you think that we can multiply the 6 and 4? Well, in this case, no. So notice that the 4 has something attached to it. It's that 2/3. If we did 6 times 4 to give us 24 and then do 24 to the 2/3, that's not going to give us the same answer as we would have here. So let's check it out with our calculators. Okay, so let's try it. So we have 24 to the 2/3 power. Gives us that. But let's see when we do 6 and then times 4 to the 2/3 power. Yeah, because the reason being is that this 4 to the 2/3, we would actually have to rewrite it in radical notation and evaluate it first, then multiply it by a 6. If we tried to multiply these two bases, that would not work at all, okay? So the idea here is that I could rewrite this as cube root of 4 squared, okay? And when I would have to evaluate that first, then multiply by 6. So really, our final answer here is just going to be 6 times 4 to the 2/3 power. That's it. Okay, let's look at part C. We have 4 to the 5th times 3 to the 5th. That's all being taken to the -1/5. Now you have options here because we do have that negative. You could bring all of this down into the denominator, or we could distribute first. It's kind of really up to you here, okay? Well, what I'm going to do is I'm going to go ahead and distribute, and then I will change it into a fraction at the end, because I don't like to start with fractions. Okay, so we do 5 times -1/5. That gives us -1 times, and then once again we do to our power 5 times -1/5. That also gives us -1. So we have 3 to the -1st. Now I still have negative exponents. I'm going to change this, so I become 1/4 times 1/3. And remember, when we multiply fractions, we multiply the numerators and the denominators. So when I do this, I get 1/12, and that's my final answer. So on some of these, you can evaluate to get your final answer. Some of them you will just have to simplify. Okay, let's try part D here. So we have 5/5 to the 1/3. So notice we have the same base, okay, and we're dividing, meaning we're going to subtract. Now on the numerator of our 5, that exponent is a 1, okay? So let's go ahead and subtract. So we have 1 minus 1/3. Don't forget, in order to add or subtract with fractions, you need to have a common denominator. So with the 1, we have to think, okay, this is the same thing as saying, right, with a 3. So if we think about 3 over 3, that is the same thing as saying 1. So now, when we calculate, we get 2/3. So I get 5 to the 2/3, and I can't really simplify that anymore, so that's my final answer. And don't forget, when you start off with rational exponents, your final answer should be written as a rational exponent. Okay, let's do our last one here, E. So we have 42 to the 1/3 over 6 to the 1/3, all taken to the second power. Okay, so here, once again, you have multiple ways of doing this, right? So we could rewrite this because notice, though the bases are the same, they both have the same exponent, okay? So we could rewrite this as 42 over 6. It's all being taken to the 1/3 because both of them, so I'm kind of reversing here. Okay, so remember when they have the same exponent, okay, so different bases, you can do that. And I can rewrite this squared. Now, you could have just distributed the 2 to the 42 into the 6. That's the same thing as well. So it's kind of up to you what you would like to do. Okay. Okay, so what I'm going to do is I notice I have a power to a power. So I have still 42 over 6. I do 2 times 1/3, which gives me 2/3. Now, when I have something like this, I can see within my parentheses 42 over 6. Can I divide that and get something nice? Actually, I can. 42 divided by 6 gives us 7. So now I have 7 to the 2/3. Okay. Now you do have to ask yourself, can you simplify this anymore? Not really. So this would just be our final answer. Okay, make sure you guys watch part 3, which now we're going to simplify with radicals.